All right. Hello, GTC community. I'm Tim Toerber from Seattle Tacoma International Airport, and happy to be here at GTC 21 to share a little bit of our story at Sea-Tac Airport, of airport that was one of the fastest growing airports in North America prior to the pandemic, and how we're looking to use AI and the Nvidia developer technology to get more efficient as a gate-constrained airport. And happy to be here with my colleague Christiaan from Assaia.
Thanks, Tim, and hi everyone. Honored to be here at the GTC with you today. My name is Christiaan. I'm Chief Customer Officer for Assaia, and before joining Assaia, I actually worked at Amsterdam Airport Schiphol. And with Assaia, we're trying to basically get all man-made delays out of the aviation system, and looking forward to after Tim present a little bit on our solution and what we're doing in Seattle. So back to you, Tim.
Great, thanks, Christiaan. So here's a little bit of the roadmap that we'll follow today in our conversation. Talk a little bit about how we became so gate constrained at Sea-Tac Airport, and then what we're hoping to do to get out of that position and to improve some performance at a gate constrained airport using some of the Assaia technology. So to start out a little bit of the history at Sea-Tac Airport, like many airports across the United States, we got our start on the heels of World War II as airports were expanding rapidly across the country. We started out as a single terminal airport with 2 satellites being added in the 1960s, one of the first underground train systems in the country for an airport, and then the parking garage being built in the 70s. This gave our airport a very unique configuration with the 2 satellites at the north and south locations, and a cemetery off to the east of the airport there that I'll reference a little bit later that continues to constrain our space. In 2008, we added a 3rd runway for additional capacity at the airport, and have quickly outgrown the capacity of just the 3 runways and this terminal configuration. In 2018, we started an airfield busing program where we didn't have enough gates at the airport, and so we're busing passengers out to remote stands where you would board your airplane via a ramp or stairs. Not the level of customer service that we'd like to offer, but it was a way for us to continue to allow flights to occur without significant delays while we expand the terminal and do some much needed construction. Which is the construction of a new international arrivals facility and a much needed renovation at our North Satellite, which will be opening up in the 3rd quarter of this year. And then I'll talk a little bit more also later about our airport master plan and how that's progressing. So Sea-Tac Airport, over just a 7-year timeline, rose from the number 16th busiest airport in the country up to the 8th busiest airport. So a huge amount of growth just in population demand, a lot of thriving businesses in the Seattle area, increased competition between Alaska and Delta Airlines, our 2 hub carriers, created the airport to see this rapid growth. Obviously, the pandemic has had impacts on airports and the travel industry at large. And so we went from close to 52 million passengers in 2019 down to 20 million passengers in 2020. But we see this recovery occurring over the next 4 years to the point where we'll be back at our 2019 levels at some point in 2024. So although we've grown this fast, we haven't been able to add a lot of infrastructure capacity. So we're still one of the lowest gate count airports, the lowest, in fact, of all the top 20 airports in the US. And so what that means is we put more passengers per gate than any other airport in the United States, 35% more passengers per gate than Atlanta, one of the busiest airports in the world. And so that has caused us to look very closely at how we use those limited resources to ensure the highest possible efficiency. Additionally, our terminal space is fairly constrained compared to some of our peer airports. We're nearly half the size as our peer airport, San Francisco, as you can see, in just 2,500 acres compared to nearly 5,000 acres at SFO, or 4,700 acres at Atlanta Airport. Here's a view of what our airport looks like if you superimpose Sea-Tac on top of Dubai Airport. So why compared to Dubai? Both Sea-Tac and Dubai run about 400 to 420,000 operations annually. Those are arrivals and departures throughout the year. And those are pre-pandemic numbers. There's largely bigger aircraft operating in Dubai, but the number of operations is somewhat equivalent. And so you can see our terminal space fits within just one of the multiple terminals at Dubai. And so just to further demonstrate our constraints here at Sea-Tac. A little bit about what we're doing to build out of this space. We've been working on a program the last few years to renovate the North Satellite. That's about a $600 million program. We've got the central terminal renovation where, if you've been to Sea-Tac Airport, this beautiful glass wall view of the main center part of the airfield has been under construction for quite some time to add some airport dining retail opportunities, as well as we're building a 450,000 square foot new international arrivals facility to welcome new passengers. And so overall, that's about a $2 billion program that we're working on, along with some back of house baggage optimization things that passengers may not see. The international arrivals facility is unique in that we'll be the second airport in the world following Gatwick with a bridge actually crossing an active taxi lane. This will be the longest bridge covering an active taxi lane in the world. So we're quite excited about that project and the additional capacity that we'll have for international flights. Beyond the current program, we're looking to make plans for a new terminal to the north side of the airport. We've reviewed many options. We've looked at different cases, but the preferred option we've landed on is a single new terminal north of the airport, which is constrained somewhat by that cemetery that I mentioned previously. And so not being able to move that facility will be constrained east-west in how we build out the new terminal. So putting further emphasis on phasing of this program so that we can get the gates that we needed as soon as possible. This program, however, is at least a decade away and comes with a price tag of about $4.5 billion are the current estimates, further putting emphasis on the need to get efficient with the gates that we have available to us now at Sea-Tac. So a little bit about our airport. We essentially run a small city moving through the terminal every day. 600 to 1,500 flights every day, that's arrivals and departures. 50 to 150,000 passengers moving through the terminal. We've got just under 20,000 badged employees that work at the airport, our own fire department, police department, essentially all of the services that you would see at a small city. So with all of this activity going on, we have a lot of assumptions about where the busiest parts of the airport, but we don't have a lot of data to back that up. And so that's why we're so excited to partner with Assaia and some of the solutions that they're offering to be able to take what you can see looking outside the terminal and turn it into useful data that we can use to actually create opportunities for efficiency and understand the operation in different ways. So one of the biggest problems that we see in my perspective as the scheduling manager at the airport is airplanes that are holding for a gate. And nobody wins when an airplane shows up at the airport. They don't have a gate available. Passengers are strapped into seats. They aren't able to get up and use facilities. There's no cabin service occurring. Passenger anxiety is rising. There's pressure on the ground operation teams to make that gate available. It's just never a good scenario. But this is what we would normally see prior to the pandemic when we were a little bit busier throughout the day of airplanes that are actually holding, waiting for gates to come available. So on average, it's about 641 minutes a month where an airplane is sitting idle, engines running, burning emissions, costing the airlines money, waiting for a gate to come open. So Airlines for America, an airline industry organization that forecasts different costs for operations, looks at their 2020 cost was for block time delays was about $75 a minute. So you take our average delays, and that equates to just shy of $50,000 a month of delay costs due to gates not being available. Not to mention all of the additional costs that airlines incur of rebooking passengers if there's a misconnection or other issues that follow on based on an airplane not having an available gate upon landing. So that takes us to some of these blind spots that we have at the airport at the gates. Looking at these two flights, you can see there's visual indicators of the pushback readiness of each of these aircraft. Looking at the airplane on the left, we have the passenger loading bridge still connected to the aircraft. There's a baggage belt connected to the cargo door. You can see there's baggage vehicles nearby, loading bags or unloading bags, and maybe fueling services are still occurring there in the right wing of the airplane. Additionally, there's a 400 hertz power cord connected to the aircraft. So you can see that airplane on the left isn't leaving anytime soon. But the airplane on the right, that aircraft has the jet bridge removed, the pushback tractor is present. There's wing walkers that will be guiding the wings of the aircraft as the airplane is pushed back. Is in a much higher state of pushback readiness than the other aircraft. But just looking at this one snapshot in time, we don't necessarily know, did all of the services that need to take place on a turnaround event occur on time or not? And so one thing that we're looking to do with the Assaia team is compare a scheduled course of activities to the when the actual events occur. So did the catering truck show up when it was supposed to? Did the fueling services begin when they were intended to? Have all of the baggage services been completed on that flight? And hopefully being able to produce a forecast of when that aircraft will actually go off block and depart its gate, making that gate available for any incoming flight. And how are we doing this? So it's really a collaborative approach where there's a model called airport collaborative decision making that's prevalent throughout Europe. It's been in the works in the US for quite some time, but largely airline and FAA focused. And airports haven't been as big of contributors to the conversation. So we're looking to change that at Sea-Tac and make this a truly collaborative approach with all of the necessary partners to really make a difference. So by taking all of this structured data, putting it into a common operating picture that all of the stakeholders can see, we'll be able to make decisions with more relevant information in real time and forecast where we have some of these delays. So as we can start to forecast when gates are available, we can look all the way back from when a flight leaves its point of origin, it's en route to our airport, and see whether that flight is going to incur a delay or not. On the right side of this image here, you can see a number of inbound flights that are early. They're going to be coming into the airport early, but they're highlighted in green that they have no gate conflict currently. And so if they're arriving early, there's no gate conflict, continue to arrive those flights on time. But if you see a flight highlighted in red, that could be a flight that likely is going to hold once it arrives on the ground and could need some different type of sequencing. And so that's where air traffic control and the FAA becomes a big partner in this effort, that they could slow down that aircraft, look at different holding mechanisms, and give them different ways to ensure that flight doesn't create additional congestion on the ground at the airport. So in addition to monitoring gates and the type of activity that occurs at a gate with video analytics, we're also looking at ways to observe vehicle movements across the airport. So at an airport, we have various vehicle service roads that allow vehicles that are servicing the flights, as well as maintenance and other activities that need to occur in these small cities that are airports. And being able to identify hotspots to improve safety at the airport is very important. Additionally, we've got maintenance that is always ongoing at the airport and taking out certain parts of the apron. And so if we can understand better the amount of traffic that actually occurs in certain areas, we'll be able to understand what those impacts would be during those maintenance events and be able to plan for those better. So this is a little bit about how we've gotten to the point where we are as a gate-constrained airport. Now I'd like to turn it over to Christiaan to talk a little bit about their solution and the Assaia application. Over to you, Christiaan.
Okay. So I think Seattle is a very good example of an, well, not an average airport, but a typical airport in the sense of how they've developed over the years. Because typically airports, had very few operations per day. They were not as widespread as they are today. So the complexity was fairly low and there was little operations going on. And typically the people operating the airport could look out of the window and could basically see everything that was going on within their field of vision. And since those early days, air travel has basically become much of a commodity, and airports have expanded and operations have become much more complex and under much more time pressure. And therefore also the operation of the airport has become more difficult because airports, if they expand, it typically takes a lot of time. It costs a lot of money. And they've, in that sense, not been able to sort of keep up with the increase in the demand for air travel. So we've seen this increase over time, and obviously COVID, has put a dent in that ever increasing number of flights. However, the expectation is that that gap will be closed, and the original expectation by IATA that the demand for air travel would actually double by 2045. That's still more or less expected to take hold, even though currently, of course, there's not so many flights, and the recovery will probably take up to somewhere between 2022 and 2024, depending on who you're asking. So if we then have that sort of pressure on the system with infrastructure development that is relatively slow, that obviously has effects, right? So if you go on your holidays, this is typically how you envision it to be. But in reality, unfortunately, it sometimes looks more often like this. And even worse is if safety becomes an aspect, because if there's so many things going on and so many different actors operating on a small space under a lot of pressure, then typically also accidents happen. And here we can see that even though there is even humans, present, in this case, an aircraft is towed into an air bridge, and on the other side, the aircraft is being towed onto a piece of ground service equipment that's on the stand. And these are all symptoms of the fact that the overview and the insight into what's actually going on in real time has gone. And that's sort of the problem at Assaia that we're trying to address. So what we see is that operations is pretty much black box, and all these symptoms in terms of lack of capacity, safety issues, on-time departure problems is sort of the tip of the iceberg. And what lies under that is that it's difficult for airports and airlines to make decisions, especially integrated decisions, overseeing all the effects that they have on each other. And that's then again being caused by the fact that there's very little real-time data available on what's actually happening in operations today. And data is important in order to streamline operations. And I think the ultimate comparison that I like to make is with Formula One, and aircraft turnaround could be compared to Formula One pit stop. And this obviously is not a very efficient pit stop. Back in the days that it wasn't optimized and it wasn't very much data driven. And if you look at Formula One today, then everything is fully optimized, everything is fully data driven. There's more than 300 simultaneous data streams coming from the car, and everyone knows exactly what to do when, and that makes it possible to make these huge increases of performance between the first pit stop that we saw and the second pit stop. And that's what we as Assaia try to come in. So what we offer, we're a software company, and we have AI software that basically consumes video streams, preferably from existing cameras, and then turns that into structured data that can be used to streamline operations, enhance safety, or overall impact positively the efficiency of the airport. And I guess it's nice to talk, but it's always better to show. So what I'm going to do now is I'm going to show you a live demonstration of the system that is going to go live in Seattle in about a month's time. So we've been preparing for this go live for quite some time. So we're really excited that we're finally at the moment to make it available to Tim, to his colleagues, to the airlines, so that everyone can benefit from it. So it's still in testing. We're bug fixing and we're doing the final testing on it. But what you can see here is, first of all, the map view that shows an overview of the airport. And as I zoom in, I can get closer and I can see different gates and which airlines these gates have been allocated to. I can also directly see actually which gates are occupied and which are empty. So I can directly get that overview. And if I hover over one of the aircrafts, it will actually give me the information, which flight am I looking at? So which stand is this, what aircraft type, what was the inbound flight number, or the origin and the outbound flight number and destination. So that's an initial piece of sort of if situational awareness that we supply. But obviously, we're all here to talk about AI and computer vision. So let us go into this specific flight right here. They will pull up the detailed flight information screen. So some of the information is being repeated, like the flight information here. And on the right side here, you can actually have the real-time camera view of the specific flight. And at this stand, we have two cameras observing this flight, one on the port side and one on the starboard side. And obviously, the interesting part is, how do we create data from this video, right? And that happens in our software, obviously, and here is a visual representation of that data. So you can see all sorts of different events that we've already activated for this specific stand, like, for example, the aircraft being on stand, the chalk being applied, the catering being connected, etc. So the gray line here is the current timeline, so we can see where are we. And the cool part is, if I click on any event, like, for example, this catering connection, it actually pulls up the image of the exact moment that the system captured that happening. And it also shows me with a bounding box where in the picture, did the AI software capture this specific event. So in this case, we can see, because the event has already ended, there's a connection, so a start timestamp, and I can also go directly to that moment. I can go backwards and forwards, and that will also show me that indeed, second per second, this is indeed the moment that the catering truck arrived here and connected to the aircraft. And I can also go directly to the disconnection timestamp, where if I go back, we'll see that it's probably going back up here. Yeah. So that's how the system detects these events. That's how we plot it, and this is how we present to the user if he's interested to know more about what was exactly happening around the moment that this occurred. They can basically pull up the video image and see that. Also, something that our system provides is a confidence level. So basically, we create a confidence level for each timestamp that shows the user to what extent they can rely on this timestamp. So if under certain situations there's a reason to believe that the timestamp might be inaccurate, the confidence level will typically be lower. I guess the aircraft just left the stand here. So this is basically sort of the overview and the detailed flight information part that I've just shown. What you'll also see is that the left side of the screen here at this moment in time is still empty, which is around notifications. So the notifications still need to be deployed, but I can actually show you how that looks for another airport like Aberdeen. So in this case, it's a much smaller airport where there's currently no flights active. But the main point why I'm showing this to you is that on the left side here, you can actually see different notifications. So what we do is we engage with the users to see what kind of situations are of interest to you, either around safety or around on-time performance and efficiency. And for example, in this case, no pre-departure walk-around was detected, which is part of the standard operating procedure at the airport. The system, again, using the computer vision, detects no walk-around in a certain time frame, and therefore alerts the user to the fact that this has not happened. And therefore, the operator can contact the ground handler in order to ask, why did this not happen? Was there a reason for it, or could you please do it still? So one of the other things that we're doing for Seattle Tacoma Airport that we unfortunately cannot show to you yet in real time has to do about vehicle tracking, and especially the tracking of vehicles that do not necessarily want to be tracked. So as we already seen, there's a lot of activity going on at the airport, And if you don't know from objects or vehicles where they are, that could lead to dangerous situations. So in order to create a full real-time overview for Sea-Tac, what we're doing is that we're also using cameras that are overlooking the wider apron in combination with our computer vision technology to basically track all the different objects and vehicles that are moving around at the apron. And obviously, you can apply some business rules to the data that's being generated. And therefore, for example, say if a baggage cart starts moving without a tractor attached to it, then that should raise an alarm in the interface. So again, we use computer vision to detect the different objects and vehicles. And we work with a pretty advanced geolocation algorithm that is also able to basically determine latitude and longitude coordinates for each of these objects, again, solely based on the visual image that we get from the camera. I also want to talk a little bit about the benefits that this creates, because the tech, obviously, it's amazing. You know, you're able to put a pair of eyes basically on each stand 24/7, and then automatically in real time continuously know basically what's going on and get alerted to situations of interest. So what does this do for airports and airlines, right? So what I did is I summed up a few use cases that I quickly want to go through to give you an idea of how the technology actually feeds into the operations and business outcomes for these kind of parties. So first of all, the alerts that I mentioned and showed is essential here. If we have any schedules from an airline as to when things should be happening, or safety situations about how things should be done, we can obviously detect, the schedule or the plan versus what's actually happening, raise an alert, and directly send it to a dispatcher. That's one way, for example, to make turnaround shorter, because if you know, for example, a catering truck is not at an aircraft when you expect it to be, you know directly, rather than someone at some point asking, shouldn't that catering truck have been here like 10 minutes ago? However, obviously, by building this database, you can also do all sorts of cool analysis on how is catering or how is fueling or how is any process performing for my flights? Is there differences per airline, per aircraft type, per stand? Is there any correlations between on-time departure and certain processes performing in a certain way? So the second use case is very much around collecting all that data and then digging into that and finding the reasons why certain aircrafts are delayed, or finding out why unsafe situations occur, right? Because typically safety audits happen only sporadically, but once you have continuous safety audits, you can basically look into all those situations and find root cause, do root cause analysis to find out how you can address it and how you can prevent them from happening in the future. So two cases around using the data to find areas for efficiency, and what's it then actually worth? If an aircraft holds a stand, that means that obviously another aircraft cannot go there. And the shorter an aircraft is on a stand, the more aircraft an airport can handle. And especially in cases like Seattle, where you're gate constrained, you're trying to maximize the asset utilization, and you're obviously trying to minimize the planned schedule turnaround time. The delays you want to minimize, and then there's always a buffer between turnarounds that you can also reduce once your operation becomes more stable. So if you have less outliers and less extreme cases, you might be able to work with less buffers. And in the research that we've done with one of the major airports in Europe, we found that if you can decrease your buffer time with only 2 minutes, that's actually the equivalent of having one additional stand during your peak hour. And again, if you can save 3 minutes from the average aircraft delay, that's equivalent to having 2 stands. And these 3 stands, depending a little bit on how you calculate it, but it's worth 11 million euro per year to the airport, if you consider all the aviation charges that they can receive additionally, but also the commercial expenses that the passengers that are sitting on those aircraft will make. So another cool thing is where we're actually combining the video analytics capability with another piece of AI technology, is where we use all the data that we generate together with other data sources, and we actually use machine learning algorithms to predict when the aircraft is going to go off block. And this off block time is actually a really important milestone, because everything that happens before that moment is sort of anchored towards when the aircraft is supposed to leave or when the aircraft is expected to leave. For example, you don't want to cater too early because some things might go bad. So everything that needs to happen for the flight to depart is anchored towards that off-block time moment. But also everything afterwards is anchored on when the aircraft is actually going to be pushed back and go into the airspace or onto the taxiways, onto the runways, and then eventually into airspace. So knowing exactly when this aircraft is going to leave is very important for all stakeholders involved. And the more accurate you know, the better you can optimize all those different processes around it. And today, almost everywhere, the latest estimation of when an aircraft is going to leave is made by a human. So they manually put in when they expect the aircraft to be ready to leave. Now, obviously, this human has many other tasks, often distracted. So these estimations are not very accurate. And we found that in all the different occasions where we compared the machine learning predictor versus the human estimation of when the aircraft is ready, that we always managed to outcompete it. Talked a bit about safety, and this video was in the presentation before, but I think it's a classical case where just by knowing where objects are, you can actually prevent million-dollar safety events. And this is a case that we could very easily seen that piece of ground service equipment was there, and as that aircraft was going towards that gate, we could have alerted the ground controller to hold that aircraft and call the ground handler to take it away. So this is obviously not something that happens a lot, luckily, but if it happens, there's a lot of cost involved. So one of those optimizations that I talked about earlier has actually to do with stand planning, right? Each incoming aircraft has to go to a stand and cannot go necessarily to all stands because of its size. So you're continuously, as an airport, trying to put the right aircraft on the right stand. And the better you know when aircrafts are coming and going, obviously, the better you can make that plan. Because if aircrafts are spontaneously being delayed, it might mean that an inbound aircraft has to hold, as Tim also showed us. So the better I know and the earlier I know that an aircraft is actually going to be delayed, the better I can adapt my stand plan and prevent these situations from happening. And it means aircraft are burning less kerosene, less cost for the airline, and also less CO2, which is a sustainability benefit. What we've actually seen, if you use these off-block time predictions to optimize stand planning, you can get really cool results. So again, for one of the major airports in Europe, what we did is we've optimized their stand planning, and we actually found that we can decrease the resources that they actually need to run the operation. So the same schedule in optimized way had a 9% less stands required, 29% less towing movements, and 55% less busing movements. So those are really big numbers. What I have to say is these optimizations were run individually. So we individually optimized for each one. If you would optimize for all three at the same time, they would probably be slightly lower. But I think it shows that the potential of introducing real-time data and more accurate predictions is huge for airport operations.
Yeah, thanks, Christian. That was really great to see where the product is headed. We're really excited to have this solution in Seattle. I know our airline partners are very excited as well. Some of how we were able to build out this project so quickly is that we had a lot of existing camera infrastructure at our airport. And so for the most part, Christian mentioned those left and right side of aircraft camera views that were built out through other efforts. We're adding additional cameras that look straight down the center line as part of a visual docking guidance system called Sea-Tac as well. So that'll give us some additional camera views. But there will be some additional follow-on efforts needed to construct additional cameras across the airport. And that'll come with a second phase. If I could share my screen for one more second, I'll show you one of the things that we came across was some of the lighting levels as part of this project. And so this is just a quick demonstration of the same gate, Sierra 12 at our airport with the older lighting styles. And then what you see below is a transition to LED lighting. And so, we're already moving in this direction to create LED lighting around all of the terminals. And we may be accelerating this so that we can improve our ability to run video analytics across the airport. both day and night. And so, again, yeah, I think it's a lot of technology that is coming together to make this work. The FAA air traffic control next generation initiatives also align well with having this ability at airports to be able to predict when activities are going to occur. And so for those next gen initiatives to be successful, airports will need technology like this. And many airports across the country have found themselves in very similar situations that we have here at Sea-Tac, where the pace of operations and the growth of airline activity has been moving faster than our ability to construct new facilities. So getting efficient with what we've got is really the solution as the rebound in aviation occurs.
Nice. Yeah. Yeah, I think because that's a question also we get a lot talking to customers or potential customers is, how does it work with rain, or how does it work in the night? And actually so far, because there is some minimum light requirement levels for airports, we've always managed to work with that. And also with rain and fog and snow, we've had some pretty extreme cases, for example, in cities like Toronto or Helsinki, or even sandstorms in the Middle East. And the most important thing there is always that we train the system with the similar conditions as it's going to encounter in normal operations. And that's basically also where we had to adapt our strategy a little bit for Sea-Tac with the different lighting conditions. But it's something that we can overcome, even though it will, of course, make our life easier as well with the new LED lighting.
Well, look forward to some exciting chat to follow on with this conversation. And thank you to Nvidia and the GTC community, and especially our partner Assaia and all the work you guys are doing to help us get efficient at Sea-Tac Airport.
It's our pleasure, Tim. And thanks for joining us in this session. And yeah, talk again soon.
All right. Take care, everybody.
Bye-bye.